Good afternoon, and welcome to today's webinar, or fireside chat, Blockchain in Smart Mobility, What Do We Need to Know? Thank you all for joining. Today's fireside chat is sponsored by ITS Canada's ATIS and ATMS technical committees. The goal of the ATIS committee is to support the membership by providing advocacy, technical exchange, and education within the field of travel of information. The goal of the ATMS committee is to support the exchange of information related to new advances in technology, best practices, open standards, and lessons learned related to ATMS and related topics. To learn more, you can visit the ITS Canada website, Technical Committees, that has an overview of everything that they do. My name is Janneke. I am the Managing Director of ITS Canada. A little bit about ITS Canada. ITS Canada, we are the hub for mobility technologies. Mobility technologies enable the safe, efficient, and reliable movement of goods and people. The hub is the place where the needs of the Canadian transportation system connect with ideas, technologies, and capabilities of our members. ITS Canada is the hub where those challenges meet solutions. Diversity, inclusion, and equality for all are ingrained in the DNA of ITS Canada. Together, we promote, encourage, and create a culture which supports and celebrates diverse voices of our members. We embrace our differences in race, ethnicity, gender, and sexual orientation. When we say we are the hub for mobility technologies, we mean the hub for everyone. We support these mobility technologies through championing the benefits, fostering and promoting innovation, integrating the expertise, products, and services of our members, and enabling communication for learning and collaboration. Today's fireside chat is hosted by Emily Webb, CEO of Dock, and guest Bilal Farooq. The format is that we have 30 minutes of chat, followed by a 15-minute Q&A. And with that, I will be making Emily the presenter, if it works. It is not working. Welcome to technology. So Emily, I might maybe just have to move the slides forward.
That's fine, no problem.
Unless you are able to take over.
Nope, that works for me. You can manage the slides. Thank you so much for the introduction, and thank you to our sponsors, and thank you to Bilal for educating our audience today on your open source blockchain framework for smart mobility applications. And I'm just going to give a brief bio of Bilal, which is down in the chat if you'd like to read along with me. Bilal Farooq is Canada's Research Chair in Disruptive Transportation Technologies and Services and currently an Associate Professor at Ryerson University. He's a founding director of Laboratory of Innovation in Transportation. In 2014, he was awarded Quebec Early Research Award, and in 2018, he also received the Early Researcher Award from Ontario. So we are going to jump into the first question.
I am able to make you the presenter, sorry.
All right, wonderful. So the first question that we're presenting today to our audience, one second please, is Bilal, can you please give a brief and simplified overview of what blockchain is?
Thank you very much. First of all, thanks Emily, and thanks Janneke for organizing this. I'm still learning about blockchain, and hopefully I can discuss what I've learned so far. Could you please move to the next slide? Great. Okay, so blockchain itself, it has the foundation in the cryptocurrency, especially Bitcoin. So around 2008, 2009, when Bitcoin came out, one of the core principles of Bitcoin was that there's no centralized entity that is managing the transactions, their validity, all sorts of management issues. So what they did was that they created a very customized data structure that was a distributed ledger. It was immutable. Once an entry goes in there, it stays there. And they came up with a way that they can manage the history of transactions of the digital currency that was happening on the Bitcoin. So on top you see this chain. So literally it is a chain of blocks. In software, each block, it is an information. A block is about 1 megabyte or so, and within that block, we have about a header and then a body in it, and the header itself, it points to the previous block. So that's how it forms a chain. And inside the block, you see that on the right side, that there are some very basic level information put in, as in if there was a transaction, who did the transaction with whom, what was the time, and so on, and some very basic information. So imagine you have 1 megabyte of space, and within that you are able to cramp in some basic information about different transactions, and then they are written to this blockchain, but not everyone can write it. Everyone has to agree upon who is going to write it, and also the content of it itself. So the point one should take here is that blockchain is a transaction management system, and that is a key point. And it can have different types. It could be public. Everyone can see it. It could be private. Only certain entities could see it. Then it could be permissioned in the sense that anyone can come and join the consensus mechanism and write on the block, or it could be permissionless in the sense that, the other way around, permissionless in the sense that anyone can write on the blockchain itself, or permissioned in the sense that, the only certain qualified permissioned entities could actually write to blockchain. And key thing is that everyone has the most updated copy of the blockchain, so they can always go and check back what transactions were taken at what point. Given that it is a very independent transaction management system that does not need centralized sort of place, everyone has equal stakes in it. It makes it very exciting, especially in the cases where transactions management is very important. So for instance, in healthcare system, pharmacy, for instance, a classic case that we are currently dealing with is that these very specialized prescriptions of a patient that has to be managed by only one pharmacy at a time. So how to make sure that this is managed at scale in a distributed manner. So we've been using blockchain there. That's one example. In logistics, there are some examples as well where the management of goods that can be managed in combination with IoT. So in general, blockchain seems to be a very exciting transaction management system that can have many applications beyond Bitcoin, many applications that have already been operational, and similarly, very exciting applications that could come our way as well. Thank you.
Thank you. Yeah, and as you mentioned, you brought in Bitcoin, and I think it's important for the audience to know that blockchain is not directly correlated with only currency or cryptocurrency. And given this chart here, great chart by Lal, you can see that these blocks are pockets of data, and within those pockets can host transportation data, smart mobility data, and It converts the information with more transparency at higher speeds, more accuracy, with the ability to have an audit trail. So it's a great visual. Thank you so much. We're going to move on to the next question. Where and why should blockchain be used in smart mobility applications?
Great question. So if you could go to the next slide. So if we look at what is happening in transportation systems, we are very quickly moving towards a cyber physical system where software data has a very strong role to play. And within this cyber physical system, there's a lot of sensing going on, sensing in the sense that beyond counting cars, but looking at exactly our movement behavior, our travel behavior, our trajectories, and so on. And also there's a lot of direct contact with the end user as a traveler through services. And so in all this context, I think there's a very and there's a lot of transactions going on as well. Transactions in the sense that whether I'm getting on a highway and I'm giving some toll, or whether I'm taking Uber, there's a transaction. Whether I'm going for a parking, there's a transaction. All sorts of transactional sort of services are being provided through this cyber physical system. And within that, if you look at the kind of stakeholders that are involved, it's not just the municipalities, but also mobility services. And now there's a big trend that we have data companies. They may have hardware like e-scooters and so on, but they are really data companies that are collecting mobility data. So all these services and also all these stakeholders, they are interested in whether it's a push or pull factor. They are interested in providing cybersecurity. They're interested in providing more control in terms of privacy. They're also interested in the auditability dimension, in the sense that who used the data, who used certain information in what way. And they are also interested in interoperability. Interoperability in the sense that I want to take Uber, at the same time I want to take e-scooter, at the same time I want to take TTC and the public transit system in Toronto. In all these multimodal sort of transactions that are happening, so how can I maintain the interoperability? So on all these dimensions, they are the key for these stakeholders. And in this sense, blockchain platform can provide a very efficient way to achieve these goals for the stakeholders that are listed. And in terms of application, it could be used for location-based services, whether it's routing through Waze, or it could be used for open data platform. Currently, municipalities, they're just putting up the data online, and that's it. But what happens with the data, who is using it, how it is used, so that dimension can be maintained through the blockchain platforms. Machine learning, it has a huge use case on blockchain. Currently, the way we are developing our models is that if I'm a modeler, I would ask for a particular data set. So I may go to, for instance, Transportation Tomorrow survey and ask to have access to that. That data is saved centrally somewhere and been copied and used everywhere. But machine learning can be done in a distributed manner without actually sharing of the data by the users through blockchain. We have shown that and so on. there are other use cases as well, like payment systems, delivery systems, mobility as a service, parking, and also tracking your carbon footprint over a multimodal sort of system. So these are some of the applications where I think blockchain could be a great tool.
Yeah, this is great, Bilal, outlining some of these connected systems, parking, traffic management systems. Really, anything can be built on blockchain. However, it would benefit greatly for municipalities and their affiliated mobility service providers to have this seamless flow of data built in the most secure way. So lots of applications here. And please, I encourage the audience to submit any questions. We have one which we'll get to at 1:30 and have 15 minutes for a Q&A. So the third question we have for Bilal is, can you tell us a bit about why you developed this framework?
Okay, so I mean, if you look at, as I said, that this whole evolution that is going on, in the end, we still are treating data or information in a way that we have been forever. But what I think is that just because of having these siloed sort of data gathering systems, whether it is a company that is collecting data, or whether it's a municipality that is collecting data, or any other entity, that is inconsistent with the kind of developments that are going on in smart city and ITS domain, and we need to think very differently towards the data. But what I've been looking at the data is that data itself, it's a commodity, or information itself, it's a commodity, and the generator of the data or generator of the information is the one who should own that commodity, and that commodity has certain value, and that value that comes out of it, that could be primarily managed by the generator of the data. And if we look at the data that way, we are able to open a lot of doors, in the sense that if someone is interested in sharing their data, they can share, but at certain value. At the same time, they are able to track how the data has been used, where it's been used. Currently, we have, once the data has been copied, that is just an forever usage possible. But here we can control in terms of the usage of data in terms and conditions. So given all this, we looked around and we thought that blockchain is ideal for this kind of paradigm shift, in terms of producing, in terms of developing a platform that can actually manage this paradigm. And that's where we came up with a 7-layered blockchain-based smart mobility data market, or BSMD. So on the left, you see that these are the 7 layers that are there. So identification layer is just where the data lies. Then we make sure that through blockchain, we are able to do peer-to-peer data transfer. Data is not, or any private data is not being hosted on the blockchain, but it is only managed through blockchain. As I said, that we are managing the transactional record rather than actually putting the data on. We bring in contractual layers where we can have smart contracts. We can have data brokers that can find the right data for nodes or entities that are looking for it. the communication layer, then at the same time the blockchain's consensus layer where the blocks are being entered, and as well as incentive layers that could be in terms of rewards or in terms of actual monetary values. On the right side, you see a very simple example which we have tested for a blockchain, and you can have individuals on nodes on the blockchain. So myself, I could be on the blockchain. I'm sharing my personal information. I'm sharing my mobile or my smartphone sensor information only if there is a smart contract that may exist between myself and, say, transportation agencies, where transportation agencies, they are looking for morning commuters who are traveling on DVP, and I'm one of those commuters. So I may be able to share that information with transportation agencies, but at the same time, we need to agree upon how the transportation agency would use it, and from which date to which date, and how it would use it, and whether there is some incentive that would come to me in return, say in the form of free TTC rides or something like that. So all this is managed through our BSMD, and this can be managed at scale. We have tested in simulations that all this can be managed at scale. So this is the kind of philosophy behind development of a BSMD.
Wow, that's a lot. Makes sense though. These visuals are great. So we'll move on to question number 4. Give us some examples where you've demonstrated. Sorry, my my chat keeps getting in the way of my questions. Please give us some examples where you have demonstrated the use of this framework in the context of smart mobility.
Yeah, so I think that there could be a lot of use cases, some of them that I mentioned in the beginning, and we have been testing slowly a couple of them. So one of the first use case that we tested was imagine having a Waze sort of app that you are using, and that is giving you real-time routing information. At the same time, it is sampling your GPS trajectories, based on which it is serving other users as well. So this is a very, very classic use case that could be looked at. And there we demonstrated that we can actually do location or personal data sharing using blockchain as a ledger or at scale, in the sense that we were able to test about 200,000 users sharing their data in real time on blockchain. So on blockchain, the bottleneck comes in terms of writing blocks to the blockchain itself. That is not a straightforward process, in the sense that everyone has to agree upon who is writing, what are they writing, and validity and all that, because it's an immutable entry. So that is the bottleneck, but we have ways to actually accommodate, and we are hoping that from 200 real-time users, we can scale it to millions of users. So that is one of the use cases that we're very happy with. Then the second use case that we've looked at is this. Earlier on, I said that these machine learning sort of models, they can actually be done using blockchain pretty in a very different way, in the sense that you actually don't need to share the data, and the evaluation or estimation of or training of the model can be done in a distributed manner, and we have done that using again BSMD, and shown that it could be done in a distributed manner, and we get same sort of training and same sort of estimates that could be done using, say, conventional methods that are currently used. Then the last use case that I want to talk about is this mobility credit market. So, and we tested this particularly on the carbon credits in your travel. Currently, these sort of apps, they are looking at one mode or one service only. But if we want to extend that to a personal travel over the whole day, over the whole week, over the whole month, and so on, we would need to account for all these different services, different modes that we are using, and doing that in a centralized way, it's just not possible because everyone wants to hang on to their bit of data. So doing that in a distributed manner using blockchain, that is possible. We have tested some of the systems in simulations and shown that, again, it works at scale.
So Bilal, you mentioned the individual's data a few times. You think that this plays a key role in a municipality's smart mobility ecosystem?
Yes, exactly. So, I mean, the example is, I mean, the recent exit of Sidewalk Labs from waterfront Toronto. So one of the big concern, one of the big hindrance of their progress was how they were managing the individual level information. So on one side, technology side, it was showcasing the forefront of technology, but when it came to data management side, the solutions they were proposing, they were very ad hoc, very old-fashioned in the sense that what they were proposing, that there could be an arm-length body that is managing the data dimension of things, and this assurance wasn't enough for the individuals. So that were actually stakeholders in the project or were living in Toronto. So that resulted in a very strong negative opinion about the project. There were other reasons as well, but one of the major reason in terms of the lack of acceptance of such project was that the individual level data management, individual level privacy, that wasn't addressed in a way that is aligned with how these smart mobility, smart cities technology should be.
Thank you for touching more on that. And we are going to move on to our last question before we take questions from the audience. Please let the audience know how they would go about accessing and utilizing your open source code that is available to public and private entities.
Great. So, I mean, the blockchain itself, there are some core level platforms available. We have been using, for instance, Hyperledger. There's some open source. There's platforms available as well. So any of these could be used, but the intelligence over it that is specifically for smart cities, smart mobility, that is where BSMD comes in. And BSMD's current implementation, it is on Hyperledger, and we have developed a repository where you can go and use it. But as it's a distributed system, as it has multiple entities, multiple nodes involved, that needs to commit to it. The key is in the process or the roadmap towards making a blockchain-based platform operational. And there, I think we need to collaborate, all the stakeholders, whether they are universities, whether they are municipalities, whether they are data companies or service providers. They need to come and form a blockchain consortium and start a chain. So you initiate a block and you start building that chain, that once we have the consortium there, we need to create this blockchain network. For that, the code that is needed, it is available on BSMD. Then we also need to make sure that the governance structure is right. So BSMD is an open, permissioned blockchain. This means that anyone can see the blockchain, but if they want to, add a new block on it, they would need to be an active node, a permission node. So there has to be some level of governance structure that can be brought in to form this sort of setup. Every entity has an ID, a verifiable ID. For that, you need some level of governance structure as well. Once that is done, then the technical details, in the sense that on the blockchain, how the smart contracts would look like, what types of smart contracts should be available, what can be done, what cannot be done, and so on. So that needs to be figured out, and then connecting it to client applications. If I am I'm managing all my interactions with all these service providers, with municipalities, with all these other entities, myself as a user, a simple user of travel, of different modes, for me it will be very, very overwhelming. So I need to have a kind of I give the analogy to the real estate. So in real estate, if I'm selling something, I won't just go and start selling myself. I would have a real estate agent who would take care of all the technical details, all the legal details, all the operational details. Similarly, here we have a concept of data brokers, and those data brokers, how would they set up? What would be the default contracts? What would be the default settings, and so on. So all these needs to be figured out in a form of a client-side application. Troubleshooting, learning from experiences. Only then we would have a blockchain that would be a fully blooming, fully operational platform for providing the kind of services that I talked about.
So Bilal, if we go back here to this chart, are these built simulations that you've tested and that are available in the framework?
Yeah, great question. So what we've done is that if you go to the repository, you would see that these use cases, and each use case can be instantiated. And the way we instantiate, there are 3 different ways that we do. One is we create multiple machines on AWS. We instantiate them, and they become nodes on BSMD, and we simulate different scenarios over it. We have used IoT devices, physical devices, with combination of AWS and normal machines as well. But all this is simulated both on hardware as well as virtual hardware.
Okay, and if anybody in the audience or anyone in their network wants to utilize your source code, is you and your team available for this, the roadmap?
Yes, exactly. Yeah. So currently we are we have given this similar sort of roadmap for a pharma company and for another application, but they are using a lot of bits and pieces of BSMD, and we are helping them in terms of making it operational. So any stakeholder who is interested, we are very happy to help them.
That's great. All right, so we have about 10 minutes left. I'm going to try to squeeze in 2 questions we got from our audience. The first question is, how do we educate municipalities, for example, about how to look differently at data versus in silo?
A great question. I think the education part should come from their experiences, right? Currently, I mean, if we look at the city of Toronto, the way its interaction has been with, for instance, these ride-hailing companies, it was the city of Toronto became active a bit, it was kind of a surprise for it, and it was a very reactionary approach. In the end, they were able to manage, and they brought in conditions in terms of data sharing and so on. But it's still very siloed, that the data that has been shared by Uber, Lyft, and all sorts of companies, that city cannot do with that much. It's very centrally stored and very few people have access to. So that was the first iteration. But in case of how they interacted with the Sidewalk Lab, they were very proactive in terms of the data dimension of it. And I think this is part of their education. So experience plays a big role. In case of smaller municipalities, they are more ready to experiment. Municipalities like Innisfil, municipalities like Belleville. So just by them being more experimental, they are able to educate themselves. So there's no one way, but these are some of the ways that could be used here as well for educating municipalities.
Great. And another question we have, which is a great question. You talked about connected systems, but you did not include freight or goods movement logistics. Is this something that you're looking to work on or include in the near future?
Yeah, so I think logistics, it's a very strong use case. And I did not specifically mention that, but yeah, definitely goods movement, especially urban goods movement, just-in-time goods movement, those sort of use cases, they are very important use cases, and they are easy wins in terms of proving the efficacy of BSMD and blockchain sort of systems.
Great, yeah, logistics would be great to get on blockchain because of the accountability in the blockchain itself. It holds every single aspect of a logistics system accountable with full transparency. So there's a lot of strength and security around this application across the board. And we'll have one more.
Sorry. Yeah. I would like to have one more comment that you mentioned, the security dimension. We have done a very thorough audit of the cybersecurity dimension of BSMD as well. If anyone is interested, we can provide them with that audit as well, in which we identify different threats, as well as how those threats can be mitigated.
Interesting, which leads on to our next question about how blockchain is regulated.
Great question. So it's self-regulated in the sense that I remember when I was talking about the roadmap, where there was a governance structure that we brought in. So we looked at different options in terms of how BSMD should be. One option was that it should be public, it should be permissionless, in the sense that anyone can join it, anyone can write on the block, and it's a complete free society. But we saw that with this we would come up with so Bitcoin is the same sort of thing. So, but with that, there would be cases that won't be very conducive for application in municipal or urban sort of environment. So that's where we brought in it to be a permission blockchain, in the sense that anyone can have access to what's written on the blockchain, but if they want to add a block on it or manage the blockchain itself, then they would have to be permissioned. And that's where the governance structure comes in. And that's where municipalities have a strong role. They should be the regulator of the system rather than completely not involved in the system itself.
Right, and I think we're entering into new space, especially in the transportation realm. Autonomous vehicles are just now being regulated with policies that are being passed through in the government processes, and same with blockchain. If there was an application within a government or municipality, there would have to be some governance and regulations around the implementation, and I think that this is what we're stepping into, and it's a very exciting time, and I think transportation is much needed for these upgrades. So to the audience, sorry, go ahead.
Sorry. So you talked about autonomous vehicles and the vehicle itself. So I conveniently did not talk about any of that dimension in the answer that I did, and there was a particular reason behind it. Is that especially in terms of driverless vehicles, where it's a mission critical system with very low latencies required and reliability and all that. So blockchain at the moment at scale is not deployable where very low latency is required. So one use case would be these driverless vehicles, where you need to give them, the braking signal, within milliseconds rather than in a minute, right? So, yes. So definitely there are applications possible, but the limitations are technological, and hopefully in next 5 years or so, by then, when we actually have more market penetration of such vehicles, we will have the underlying blockchain technology available as well.
Right, at which point the connectivity of smart city infrastructure will be critical because of the communication that's going to be passed on to entity after entity for the flow of traffic to be seamless and the cars to be connected. And yeah, this would be a great application for that entire infrastructure.
Yeah.
So I just want to thank ITS Canada for hosting us and sponsoring this webinar and fireside chat. Bilal, thank you for your time, and I encourage anybody to reach out and ask questions and discover the open source framework. It's really a great piece of academic work. So thank you.
Thank you, Emily, and thank you, Yannicka, and thank you, ITS Canada. It was a very interesting discussion. I really enjoyed the questions that were asked.
Thank you. Have a great afternoon.
You too, everyone. Bye.